Hi, as Rebecca said, I'm Brett. I'm from Wiley & Co. I want to thank the RDCs for putting this event on. I think the calibre of the material that was presented yesterday was excellent across the board. And I really, whenever I'm presenting at conferences, I find it really interesting the way that a diverse array of speakers to kind of have all of this content that intertwines and makes a coherent message. A little bit about us. We design and engineer and construct a lot of infrastructure across the food and agricultural supply chain. So a big team of engineers and designers that design sale yards and food processing facilities and cold storage facilities and all of those sorts of things. And then we construct them and work with our partners across industry and also work in with the RDC network. So a lot of our scope year on year across industry is about delivering assets that actually add value to the food supply chain and the agriculture supply chain, and we bring products like this to market with our partners, and some of our partners are here today presenting about the challenges within their areas of industry. So that's what we do. I want to talk about AR, obviously, but I want to take a little bit of a different spin on AR based on what we saw yesterday. So AR is a display mechanism. It's really a way of as the name suggests, we're augmenting people's experience of the real world by putting some additional information between them and the real world. And a lot of the stuff we looked at yesterday was about either from a retail perspective or from a training perspective, giving people an engagement around some material. So driving up their engagement on a particular product in a retail experience or a marketing experience, or potentially driving up their engagement around some training and some education and those kinds of things. And so again, we're using it as a display mechanism to heighten people's experience. But I think that as much value as that adds, I think there's another area that we can push into from an AR perspective to start to augment the experience of people and have them add greater value across our business and supply chain. So Wiley and MLA have been working together for a couple of years on a few different projects researching in this space. And I want to give you sort of some background about why we tackled AR in this area and why we thought that was really important. So I talk about this a lot whenever I'm presenting at conferences, but I see there are two major problems that exist within all businesses, and it comes down to two things. One is decisions are hard, and the other thing is people are stupid, okay? Humans are just terrible things. We really need to find a way to make them better at all of the things that we want them to do. So maybe stupid's not a fair word. They're not malicious. Let's say they're inconsistent. So I think AR can help us with their inconsistencies, and we can probably find a better way to augment them so that they're just better at doing the things that they're currently terrible at doing. So I want to talk about why they're inconsistent. Some of you might have come across this field, behavioural psychology, and specifically this guy. His name's Daniel Kahneman, and he won the Nobel Prize for his work in behavioural psychology. And he coined a term or coined a phrase that I'll get to in a second, which I think sums up why augmented reality actually works, why it is going to make a difference to how our people do their jobs. And the concept is, the concept's a thing called what you see is all there is. So I'll show you an optical illusion, and then I'll ask some questions, but I'll ask the questions worded in a very specific way. So when I put this graphic on the screen, and I'm sure loads of people have seen this graphic before, if I ask you which of the orange circles seems bigger, hands up for the one on the left, hands up for the one on the right. Okay, so literally nobody put their hand up for the one on the left. Now, I chose my words carefully. I asked which one seems bigger, and the reason I say that is because most of you know that the circles are the same size. So if I show you that the circles are the same size, now you know that, right? But if I take that information away and I say, which one seems bigger, the one on the left or the one on the right, you still think the same as you did before, right? So I've presented you with information that makes you better at your job, and then I took it away, and you're still terrible at your job. Okay? So if I look at that from a statistical perspective, if I present you with a series of problems and I ask you to make some decisions, and in decision one, you've got 50% of the information, and in decision two, you've got 5% of the information potentially about that decision you need to make, and in decision three, you've got 95%. So we know that the quality of your decisions is going to be varied based on the amount of information that you have available to you at the time of making decisions. If I take away the information you don't know and I ask you to make a decision, you'll make that decision. And when I say, hey Michelle, hey Sean, how do you feel about the decision you made? You'll be like, I did good. Yep, look at me, making decisions, okay? And what we know is that you did terrible because of all of the material that wasn't available to you. So humans make terrible decisions, and what we have across our food and agriculture industry is we have decisions being made on subjectivity day in and day out. People look at something and go, based on my years of experience and all of the data that my brain has in its available context right now since I last had coffee, I make this decision. Not based on all of the data across industry, not based on all of the data in my entire career, just based on the couple of things that are rattling around in my head at the moment. And so what we have is that we actually have poor decisions being made through subjectivity, and I think that this is where AR can help, and this is some of the research that we were doing, have been doing with MLA. So in the States, in the US, they do classification of meat, and a number of years ago they did a study to determine, are they classifying their meat well? And what they determined was they were doing an appalling job. But they were doing the best they could. They threw lots of people at it, and in every one of their facilities they had these trained operators who were designed to classify meat. And it's not just in classification of meat. I'll get to some other industries later on. It's also in contamination control and all sorts of other areas where we just have people that we feel like we've trained and we deploy them into the workforce and we say, can you do your very best? And they do their very best, but we don't have great systems to determine if they're actually doing a fantastic job or not. So, as I said, in the US, they did this study and determined that they were what they called something and what they measured it to be later on in terms of their classification was just all over the shop. So it's not beyond the realms of possibility that across all of our supply chains in Australia that we have judgment calls being made based on subjectivity and that there's an opportunity for us to enhance that. So I want to show you a really quick video that I've cut up from some content from the MLA about how we grade meat in Australia.
Eye muscle area is an indicator of yield and measures the size of the longissimus dorsi muscle in square centimetres. Marbling. Marbling, which refers to the fine flecks of intramuscular fat, has a direct impact on the flavour and tenderness of some cuts. MSA uses two systems to measure marbling. The OzMeat score provides a general indication of the amount of marbling, while the MSA score looks closer at marbling distribution and fleck size.
So across, there's a thing in Australian red meat sector called MSA, Meat Standards Australia, and there's an insane amount of science behind it, that if you collect these attributes of a piece of meat and collect them accurately, and then you run them through an algorithm, you can actually determine the eating quality of that piece of meat, objectively. The challenge that we have is how we collect those attributes. And the way we collect those attributes is we put people in funny hats and train hundreds of them and deploy them across industry and assert that they'll do it consistently day in and day out. And it doesn't matter whether their dog's got run over or they're having a divorce or they're, any number of other things that are going on in their life that might erode their concentration. They've been doing it in a 5-degree room for 7 hours already, and they might just be over it. So we don't have great systems to allow for adjusting for the inaccuracies that subjectivity bring into this activity. So the science is great. What we need is a better way to actually collect those attributes, because ultimately when you're on your 700th meat carcass for the day and you're counting square centimetres with your finger holding a piece of plastic over the piece of meat, that's going to get tedious and you might just miscount. But surely calculating the area of something is something that computers can do really well. But it's also a really variable environment. Bits of meat swinging around and cold and water splashing everywhere, and setting up a machine to do it isn't particularly practical either, and that's why I think we need to augment the workers. So the idea we came up with was developing a meat grading prototype app where we could basically say, using augmented reality and cameras mounted on the workers and some science and some software, can we actually calculate the collection of those attributes in a more efficient fashion? So we set about building some software that would actually do that. So looking at marbling score and looking at eye muscle area and looking at the depth of fat and the colour of the meat. This is another attribute that we collect, is actually what colour is it, and so the people actually have these little coloured swatches and they hold them up against the meat and they try to make a determination, holding a torch, what colour the meat actually is. So surely that's something else that computers could do. So we set about writing some software that would do that. And we did a research piece, which you can download from the MLA's website, where we sort of canvassed, this would be 2 years ago, all of the hardware that existed in the AR space and identified that we would use this, a piece of technology made by a company called Vuzix that Intel had invested $25 million in, and that led to a lot of other people investing in that company, and then Intel sold their shares. And Vuzix produce genuinely some of the worst hardware I've ever come across. I noticed one of the speakers yesterday had a Vuzix Blade on, and I was like, wow, we should have used that. And then he said it was terrible. So, look, they make them, they sell them, we used it. That's all I can say about that. Possibly the learning from this is that a lot of these problems can be solved with software, but 2 years ago when we were embarking on this project for the first time, the hardware just wasn't there yet. So we wrote this piece of software, and this is kind of the software displayed on a mobile phone, but essentially what we did was say, okay, I'm going to take inside the green square, I'm going to take a sample of the colour. In the bottom corner over here is a replication, and all the black area is the area that I'm actually going to calculate the colour of, and all the pinky bits here are the white bits up there, and along this edge is my colour swatches, and what we've determined is that blue dot that's what colour that piece of meat is. And if I grade a piece of meat every single time, and it's that colour, that's the answer that we're going to get every time. So we did that with meat colour. We also did it from a calculating of square centimetres, so all of the areas that have the green dot in are actually meat, and then you'll see when we get into the border area and the white area, we don't put a green dot in it, we don't count the square centimetre. And so we can actually calculate those things objectively. And the computer doesn't get tired when it's on its 600th piece of meat for the day, and it doesn't confuse 63 centimetres with 36 centimetres. Those things just don't happen. So we're actually getting to the point where this sort of stuff can calculate objectively, and we can make that better. But we're doing it with a wearable computer, albeit a terrible one. So that was our experience in sort of producing that program and looking to augment those people in that environment and remove some of the subjectivity out of the supply chain. So after our experience with the Vuzix, we said there's got to be a better way. Who's funded better? Well, Google are funded better. So we ported our software to Google Glass, and what we learnt was the software still worked, but Google Glass is not something you can put into an 8-degree room or a 6-degree room with water splashing about either, and the battery life's terrible and all those sorts of things. Now, I'm sure Dave Francis over there at Virtual Method is waving at me saying we should be trying his hardware, and I totally accept that we probably should give that a go at some point in time. But what we learned is that the software can make people better. And that, I think, is the lesson from our perspective. Is the content yesterday about engaging people and entertaining people and training people is great, but if we can build software that makes people better at their job when they are doing their job, that is actually where we can really start to drive some value. So we actually think other areas of application. I know John from Tees is presenting shortly, and John told me that he's going to present about some problems that industry needs to have solved. And that's something that we want to get to as well. So we think that some neural network kind of technology can actually help us identify marbling better. It can help learn over time and start to identify different things within industry. We believe it can identify parasites. So we can take data like this that says, here are the instances of liver flukes in a particular piece of meat. If we had photos of all those instances and we trained a neural network on that, we could actually build camera systems that would identify them better than people ever would. Now, there's a lot of cameras involved, and we need to build databases of 5,000 images and 5,000 images of every single angle of a photograph of a piece of meat that has liver flukes. And if we have that kind of volume of information, we can build those neural networks, and we can start to build those training algorithms that are going to visually identify that stuff, and those systems won't get tired, and those systems won't get distracted. So those are the sorts of things that I think that AR is going to bring to our workforce going forward. And on an Australian strategic kind of basis, this is a sort of area that I think we're going to be able to propagate across several industries. So anybody who is familiar with how sultanas are colour graded, they get this big 1-ton box of sultanas, they take 5 kilos out, they spread it out on a piece of paper. Somebody who's trained looks at it and goes, that's a 4, and somebody writes it down, and that's what colour that 1 tonne is considered to be. Okay, again, that's something that we should have computers doing, and there's no reason those people can't be wearing headsets with cameras and those sorts of things. Imperfections in potatoes, conveyor belts flying along, and you're supposed to spot a potato that's not particularly good and pull it out. We can have cameras that do that. We can have AR headsets that can project in front of somebody and say, that potato that you're seeing a green line around is good, and the one you're seeing a red cross through is bad, and you need to pick it up and throw it in the bin. Those are the kinds of experiences that we can start to develop. So to close, what I want is we need you. We need all of the technology-focused people in this room and in industry to work with people like us and people like Tees and people like the MLA to kind of bolt on the IP that exists in other areas and write this software and find practical means of delivering it to the faces of the people at the coalface within our industry so that they've got these headsets on, they're experiencing this, we're making them better at their job, we're making them more efficient, we're making them feel more valuable, and they're actually contributing greater value to the industry. So that's what we're about. Love to have conversations with people about areas that they think that this technology can make a difference in that reduction of subjectivity.